All right, so get ready for a deep dive into something kind of weird, right? We're talking about, like, cocaine and bees.
Yeah, it's definitely not your average Tuesday afternoon topic.
No, not at all. But trust me on this, the science behind it is, well, it's pretty fascinating.
Yeah, it's one of those things that makes you scratch your head at first, right? Like cocaine is supposed to be this, deterrent for insects, right? It's what plants use to keep them away. But then it turns out, boom, it's addictive to mammals,
Yeah.
us included. So, yeah, it's a head scratcher for sure.
So we're not talking about bees, like, snorting up and going crazy like a bee version of Scarface, are we?
Thankfully, no. No bee cartels, no tiny little razors.
Okay, good to know.
This paper we're looking at is from the Journal of Experimental Biology, and they took a much more, shall we say, refined approach. They gave, like, carefully measured doses of cocaine to honeybees, and then they focused on changes in their waggle dance.
Okay, hold up a sec. For those of us who, haven't been formally introduced to the wonders of the waggle dance, what exactly are we talking about here? It sounds kind of cute, like a bee conga line or something.
Well, it's not quite a conga line, but it's definitely up there in terms of, like, amazing insect communication. So picture this, right? A foraging bee, out and about, finds a killer spot for food, nectar, pollen, the good stuff. They head back to the hive, and then bam, the waggle dance begins. It's their way of telling their buddies, hey, I found the mother lode.
So wait, they dance to give directions?
Exactly. It's like their own little GPS system, but with more, groove.
Okay, I'm intrigued. So how does cocaine fit into all of this? Where does the party drug come in?
Well, that's the genius part. The researchers, they use this waggle dance as a kind of like a natural bioassay, basically a way to see how cocaine messes with the bees' perception of reward. By watching how their dances changed, they could figure out if the cocaine was, making them think the food was even better than it actually was.
Gotcha. So, armed with our newfound knowledge of bee disco, let's talk about what went down when the researchers introduced the cocaine. What did they find?
Well, let me tell you, the results were pretty wild. The bees that got a little taste of that cocaine, they were way more likely to bust a move after finding food. And not just that, their dances were like way more intense, more energetic, like they were really trying to sell it.
So they were basically hyping up the food like, yo, check out this nectar, it's the bomb.
Pretty much. It's like the cocaine was messing with their reward system, making them think their finds were even more valuable than they actually were. It's kind of similar to how cocaine affects, dopamine systems in us mammals.
Which is kind of wild when you think about it. I mean, it suggests that cocaine affects insects and mammals in these, like, surprisingly similar ways, right?
Exactly. And that right there, that throws a wrench into the whole idea that insects and mammals have totally different reactions to cocaine. It hints that maybe, just maybe, the mechanisms behind addiction, they're more similar across species than we first thought.
Okay, so this is where things get extra weird for me. They found that the bees only really went all out with their dances when they were back in the hive, surrounded by all their bee buddies. It wasn't like they were out in a field somewhere, high as kites, dancing solo. What's up with that?
That, my friend, is the million-dollar question.
Yeah.
It really shows you how complex this whole thing is. It's like the social scene of the hive. It plays a huge role in how cocaine affects the bees. It's not just a simple case of cocaine equals more dancing. There's more to it.
So maybe it's less about the drug itself and more about, like, bragging rights, like, hey, everyone, look what I found. You're welcome.
It's definitely a possibility, and that's where things get even more interesting. They found that, get this, when they cut the bees off, like cold turkey, after giving them cocaine regularly, those bees, they started acting like they were going through withdrawal.
Wait, seriously, withdrawal? Like, for bees, we're talking, like, the shakes, the cravings, the whole shebang.
Well, maybe not the whole shebang. Not exactly like a bee going through rehab.
Okay, good.
But yeah, it was surprisingly similar. They found that when they took away the cocaine suddenly, the bees who'd been getting regular doses, they bombed their learning tasks. Like, way worse than usual.
Huh. So even insects with their, tiny brains and all, they experience something like withdrawal when you take away their cocaine fix.
Seems that way, yeah.
Wow, it makes you wonder what else we've gotten wrong about, the whole insect world. But before we go too far down that road, can you, bring it back to the bigger picture for us? What's the takeaway here?
Right, so this is where we got to put on our, evolutionary biologist hats.
Okay.
The paper, it throws out this really interesting idea, and it's that the whole addictive thing with cocaine in mammals like us, it might just be a side effect
A side effect.
of its original purpose, its main gig, which was being an insecticide.
Hold on, so you're saying our very real, very serious problem with cocaine addiction, it's just, what, an evolutionary oopsie?
Well, it's definitely complicated, right?
Yeah, I'd say so. It's a bit of a raw deal for us, don't you think?
Keep in mind, cocaine, it really messes with those neurochemical systems. The ones involving dopamine, that feel-good chemical, and other biogenic amines too.
Biogenic what now?
Biogenic amines, they're basically like these organic compounds, messengers between nerves. They're like super important for all sorts of things, movement and, that whole reward processing thing, both in insects and us.
So cocaine is kind of like that one friend who comes to the party and just like trashes every room in the house. But instead of rooms, it's those systems in our brains.
That's a pretty great analogy, actually. Yeah. The paper's saying that this effect on our reward systems, it's like an unintended consequence of its real job, which is being a, hardcore insect neurotoxin.
Yeah.
It's like you're trying to, I don't know, swat a fly,
Yeah.
and you accidentally set off a disco ball.
Okay, I think I get it. But still, you'd think that evolution, after all this time, millions of years, would have, like, ironed out that wrinkle, right? Like, why wouldn't mammals evolve to just, like, avoid this stuff completely if it messes with us that badly?
You've hit on a big question, like one that still has scientists scratching their heads. It could be that the evolutionary pressure, the need to avoid cocaine, it just wasn't strong enough for most mammals.
Yeah.
At least not until humans came along and figured out how to, extract it and make it, way more potent. Or who knows, maybe there are other things going on, stuff we haven't figured out yet.
Speaking of humans and our knack for getting into interesting situations, there's another thing from the study I found pretty wild. Apparently, the cocaine, it didn't, like, turn the bees into little buzzing maniacs. They weren't hyperactive or anything.
Oh, right.
They just, like, way overestimated how awesome their food was and then did their little dances about it with, extra enthusiasm.
Exactly. It's really important because it shows you that how cocaine affects you, it totally depends on the dose. And it's different for different species, right? So for insects, high doses, yeah, they can really mess up their movement and make them all twitchy and stuff. But low doses, like what they used in this study, seems like the main thing is it just throws off their reward perception.
So it's less about turning into a bee version of the Energizer Bunny and more about, like, having a skewed perspective on the quality of pollen.
There you go.
Wow.
Fascinating. And I think that's one of the coolest things about this whole study, right? It makes us rethink everything we thought we knew about, brains, behavior, even in creatures that we often think of as, simple or insignificant.
Yeah.
It's like this little window into how connected everything is on this planet.
Yeah, it really makes you feel, I don't know, kind of small in a way, doesn't it? Like, we put ourselves at the top of the food chain, but here we are, finding out we've got more in common with a bee than we thought, at least when it comes to, things like addiction. It really makes you think, right? Like, if something like addiction, something we think of as so complex, could be traced back to, well, this kind of ancient origin story, what else, What other human experiences might have these weird, unexpected connections to, like, the rest of life on Earth? Things we haven't even thought of yet.
It's a great question, and honestly, we're just scratching the surface here. This research, it's like opening a door to a whole new way of thinking about addiction.
It really challenges our perspective, doesn't it? We tend to think we're so special, at the top of the evolutionary ladder and all that. But here we are, finding common ground with bees over something as intense and potentially destructive as addiction.
Exactly. It reminds us that we're not separate from nature, not even close. We're part of this grand, interconnected web, whether we realize it or not.
And who knows what other weird and wonderful similarities are still out there waiting to be discovered. Maybe we'll find out that ants have, like, their own version of rush hour, or that caterpillars deal with, FOMO about the latest leaf trends or something.
Okay, well, those might be pushing it, but I get what you're saying. There's so much more out there to learn about how other creatures experience life, even the smallest ones.
For sure. And that's why we do this, right? To keep asking those questions, to keep exploring.
Absolutely. Never stop being curious.
So on that note, we'll leave you with one last thought to chew on. What if those things that make us human, those experiences we hold dear, what if they have roots that go way deeper than we ever imagined? Roots that connect us to the vast and incredible tapestry of life on Earth.
It's a thought-provoking question, to say the least. Keep pondering those mysteries, and we'll see you next time for another deep dive.